All right, welcome everybody. Let's do this. So lesson 14, graphing factored polynomials. So this lesson is very deep, right? There are a lot of things that we need to kind of learn in this lesson. So what I'd really like you to do, I know it sounds corny, but believe that you can learn this material. I want you to push through, fight. How bad do you want to be successful? I want you to push through a lot of the things that we're doing for today. You can do it. It will be a lot, but it will be really good once we learn all the concepts for this lesson. And if you feel like it's a lot for one day, then maybe this lesson will take 2 days for you to fully get. But we have to go through it, okay? So what I'd like you to do is first, let's read this problem. If you want to read it with me or by yourself, pause the video and let's zoom in a little bit and let's see what's happening here, okay? Let me fix the, okay. So here, you could pause the video and do it by yourself or follow me. It says an engineer is designing a roller coaster for younger children, right? So we have some roller coaster going on, and it says for young children has tried some functions to model the height of the roller coaster during the first 300 yards. So we know that the distance from the beginning to the very end has to be 300 yards. Okay, like the roller coaster, I don't know what it's going to look like, but I know from the beginning of the roller coaster to the very end, it's 300 yards. So she came up with the following function to describe what she believes would make a fun start to the ride. And she's saying that the model for this roller coaster is going to be this polynomial, okay? So where h of x is the height of the roller coaster, so here h of x is the height of the roller coaster, and this is in tens of yards, right? And when the roller coaster starts, it'll be 100x yards from the beginning. So now, don't freak out by this notation, okay? Let's just keep going. It says, answer the following questions to help determine at which distances from the beginning of the ride the roller coaster is at its lowest point. Okay, let's just kind of go through the questions. Let's look at number 1, or letter A. It says, if you were to graph this polynomial, which quadrant would you focus on and why? So here, if we have this polynomial, right, let's graph it. Okay, so what I want you to do is take out your calculator, take out the Wizzy, whatever you need. You have the calculator, and let's, okay, so I want you to, let's reset the calculator. Second, memory, reset, enter, all RAM, reset, bam. Okay, so now it's reset. Let's go, y equals, let's plug in this function into the calculator, right? So if I'm gonna plug this function in, it's negative 3x to the 4th, and then plus 21x to the 3rd minus 48x squared plus 36x. Okay, so we know that this is the polynomial for this function, and now what we're going to do is, oh my bad, here what we're going to do is we're going to graph it. So let's go graph. Okay, let's see, what does it look like? Okay, so here notice that it goes up, then down, then up, then down. But let's look at the question. It says, which quadrant would you focus on? Like, if I'm thinking of a roller coaster, remember, this x-axis over here has to be the ground. So if this is the ground, I only want to focus over here on the top right area. So if I just want to look at this graph over here, let's go to window, and let's change the window like this. If I have x min is 0, notice what happens to my graph. It only shows me the right side, right? And now if I go window, like if I only want to see this top area, let's go to window, and let's go y min, let's put that at 0. And now we hit graph, and notice that we're only focused on this quadrant here. So this is a roller coaster. It goes up, then down, then up, then down. So what I want you to do is, let's graph this over here. Take your time and graph this function. Notice that the zeros, this is a 0 right over here. And it also hits 0 at 1, 2. So it hits 0 over here. And then it also hits a 0 at the 3. So it's at 1, it's at 2, and it's at 3. And if I were to graph the polynomial, it should look just like this. And let's see, how high does it go? It goes, let's see, let's drag the cursor. It goes about, you see our y function here, it's about 8. So if this should be 0. This should be 1, 2, 3, 4, 5, 6, 7, 8. And this is 9. So it should go up over here, down, then up. Okay? So now this is our polynomial and this is the graph. So for part A, we're done. Okay? Now let's look at part B. It says graph the polynomial in quadrant 1. Okay, we did that. And how can you adjust your window so you can only see the first quadrant? Well, here we want our window like this. We want our x min to be 0. We want our x max to be 10. And we want our y min to be 0. And we want our y max to be 10. Okay? If you feel confused why you want this to be your window so I could just see this, just raise your hand and I could show you. Okay? Let's look at part C. It says label the zeros. Okay, so we did that. This is my first 0. This is the second 0. And this is the third 0. So we know x equals 0, x equals 2, x equals 3, right? Remember, if I plug in 0, 2, or 3 into this function, the whole thing becomes 0, okay? So here, what do the zeros of this polynomial represent in the context of the problem? What do these zeros represent? Pause the video and try and write it for yourself. Or if you want here, they represent when the roller coaster reaches the ground. Okay? All right, let's move on. So here, let's zoom out a little bit. Let's put this over here, and let's go through this. All right. So this will be a lot to do. Okay. So let's look at this part here. It says let's look at E. It's saying, what do the zeros mean in terms of distance from the beginning of the ride? So what do the zeros mean in terms of the distance at the beginning of the ride? Hint, reread the problem. How far is the starting point to the end of the ride? So here, we talked about it at this point over here, right? Here, let's see. When we have, oh, let me fix this. Okay. When we have this here, what do the 0, 2, and 3 represent? Remember that, let me get the red over here, that from the beginning of the problem, that the distance, the roller coaster, the distance is from 0, this is from 300 feet, right? So the distance from here to here is 300 feet. And how high does the roller coaster go? It's in tens of yards. So it's not 1 yard. Like the roller coaster doesn't go at 1 yard. It goes at 10 yards, then 20, then 30, then 40, then 50, 60, 70, 80, 90. So it's going this high up. All right. So if we were to answer this question over here, what do the zeros mean in terms of distance? We just know that it ends at 300 feet and it should end somewhere at 80 feet high. Like it goes up to somewhere around 80 yards. And this should be yards as well. Okay? That's all. Let's look at this part. How can we find the highest point in the roller coaster, in which the roller coaster reaches? Okay? Now this part, where is the highest point of the roller coaster? It's right here. Okay? So how do I find where that point is? Like, how many feet to the right does it go, and how high is this highest point? We know it's somewhere between 80 and 90, but let's take a look. What I want you to do is, this is going to be a nice calculator trick. So here, let's go to, if I want to find this top point, I go second, trace, right? And now here, I want to go to number 4, and it says maximum. So once I hit maximum and I hit enter, notice it says left bound, right? Doesn't that look very familiar? Let's see. Where is my cursor? X equals, okay, so here you just have to kind of play with it. Here, notice that my X value is at 2, and now we bring this all the way over here. And now here, if I know this is the maximum, right? So here, I hit left bound, I go to the left of it, then I go to the right of it, I hit enter, and then it gives me a guess, I hit enter. And now here, this is my maximum. It's at 0.5. So I know that it reaches about 0.5. And what's the maximum height? It's about 8.5. But this is 8.5. This is about 85 yards where it reaches the maximum. Okay? What if I wanted to see where the next peak is? What if I wanted to calculate where this point is, right? So then you would do the same thing. You would just go second, trace, maximum, and then you're going to bring this guy all the way down, and then we could find another one. And this is called a relative maximum, okay? So here, let's do this. So my relative maximum, or the highest, actually no, the highest here, let's write that. The highest point the roller coaster reaches is 85 yards. And it hits 85 yards when the roller coaster is about 50 yards away. Okay? All right, good. Now let's look at the next part. How much time are we? 11 minutes and 40 seconds. So this is the part where I said, I know it's a lot. You gotta push through this, all right? You can do this. Let's continue. Well, I'll make it for the next video.